300 horsepower from a 1-liter motorcycle engine. That is what the Kawasaki Ninja H2R delivers. This is not a street bike. It is not built for comfort. It is not built for traffic. The H2R is a track-only machine engineered around one objective: compress as much air as possible into a 998cc inline-four engine and survive the stress that follows. The heart of the Ninja H2R is its centrifugal supercharger. Unlike a turbocharger, which relies on exhaust gases to spin a turbine, a centrifugal supercharger is mechanically driven directly by the engine. As RPM increases, boost pressure rises in direct proportion. More air forced into the combustion chamber means more fuel can be burned. More fuel burned means more power, but compressing air generates heat. Heat is the first constraint. As intake air temperature rises, density drops. Lower density reduces combustion efficiency. Extreme heat also increases the risk of detonation, uncontrolled combustion that can damage pistons and cylinder walls. To manage this, the H2R uses advanced intake design, optimized airflow channels, and precise fuel mapping. Even so, sustained boost creates enormous thermal stress on internal components. Then there is rotational speed. The H2R's engine revs beyond 14,000 revolutions per minute. At that speed, pistons travel up and down thousands of times per minute. Connecting rods endure extreme tensile and compressive forces. Bearings experience immense load cycles. Mechanical stress increases exponentially with RPM. Higher rotational speed increases airflow through the supercharger, which increases boost pressure, which increases cylinder pressure, which increases internal force. Power climbs, but so does risk. The supercharger impeller itself must withstand enormous centrifugal force. Spinning at extreme speed, any imbalance could destroy the system instantly. Precision machining is mandatory. Now add aerodynamics. The Ninja H2R is fitted with carbon fiber winglets. These wings generate downforce at high speeds, pressing the front wheel toward the ground. At 200 miles per hour, air becomes resistance and stability simultaneously. Downforce improves control, but it increases drag. Increased drag requires more power to overcome. More power demands more boost. More boost generates more heat. Everything connects. The chassis must also survive these forces. High horsepower without structural rigidity leads to instability. The trellis frame is engineered to balance stiffness with flex. Too rigid and the bike becomes unforgiving. Too flexible and it becomes unstable at speed. Then there is traction. 300 horsepower on two wheels introduces another limitation: tire grip. At high throttle input, torque can overwhelm the rear tire. Electronics help manage delivery, but physics still governs friction. The contact patch between rubber and asphalt determines how much power can actually be transferred. You cannot accelerate faster than your traction allows. And because the H2R is track only, it avoids emissions restrictions and road noise regulations. That freedom allows it to operate without street legal constraints. But that freedom removes everyday practicality. The machine is optimized for performance bursts, not durability in traffic, not long service intervals, not comfort. The H2R exists in a narrow envelope: maximum power, controlled environment, short duration intensity. Push it beyond cooling limits and heat becomes destructive. Push it beyond traction and stability vanishes. Push it beyond mechanical tolerances and components fatigue. The Ninja H2R represents what happens when engineers chase airflow and combustion efficiency without compromise. It is not the most practical motorcycle ever built. It is one of the most mechanically aggressive. 300 horsepower from a liter engine is not magic. It is compressed air, extreme RPM, structural reinforcement, and controlled thermal management operating at the edge of material limits. Because at this level of performance, speed is not the only challenge. Survival is...